All right, class, guess what? This is our last chapter, our last 8th grade standard, your last pre-algebra chapter with me. So let's get this done. That means we're close to the end of the year. All right, chapter 16, real numbers and Pythagorean. Maybe you've heard of the Pythagorean theorem before. We're not going to quite do that. You'll get into that next year. But let's start with just talking about exponents. Some vocab. The expression 3 to the 5th is called a power. The base is 3 and the exponent is 5. So that's some good vocab. The entire expression is called a power, and then just the base is 3, exponent is 5. A power is a product of repeated factors. The base of a power is the common factor. The exponent of a power indicates the number of times the base is used as a factor. So that's important, and I think you all mostly know this. Exponent tells us how many times we're multiplying that base or factor together by itself. So if I have 1/2 raised to the 5th power, that's telling me that I have 1/2 5 times. So if I wanted to write it out, I would say 1/2 times 1/2 times 1/2. I would write that 5 times, and then I would evaluate it. I would multiply them all together. All right, let's get into some examples. First one, writing expressions using exponents. So we want to write each product with a power. So we want to represent it with exponents. So I have -7, that's my common factor, so that's going to be my base. And then how many times do I have that -7? 1, 2, 3 times. So I'm going to raise it to the 3rd exponent. So that's how I would write it using exponents. Part B, I see pi times r times r times r. So I see two different, what do we want to call them? I see two different, what they're going to be is bases or factors. So I see pi being multiplied twice. So that means I'm going to write pi raised to the power of 2 times, now I have r as another base or another factor, and I have 3 of those. So I'm going to say r to the 3rd. Let me rewrite that 3. So that's how I would write this. If there's more than one base or factor, you would have 2 separate terms. So that's our answer there. Let's move on. Evaluating expressions. Evaluating means to solve. So I want to actually solve -2 to the 4th power. So I have -2. It's telling me I have -2 4 times. So I'm going to write it out. -2 times -2 4 times. Now let's evaluate it. Let's actually multiply those together. -2 times -2 gives me a +4. Now just do 4 times 4. My answer is a +16. Let's look at part B. Notice what's different in part B than part A. I'm seeing -2 to the 4th power, but it's a little different. I'm missing those parentheses that I had in part A. So this time, when the parentheses are not included, that means you're not including the negative. The negative kind of just stays out front, kind of hangs out front. Now I have 2 is just your base being raised to the 4th power. So I'm going to multiply 2 together 4 times. Keep that negative in your answer. 2 times 2 is 4. 4 times 4 is 16. So this time our answer is a -16. So that's the difference between parts A and part B, whether there's parentheses or not. If the parentheses are around that negative, you include it. If it's not, like in part B, we bring that negative down into our answer. All right, your turn. Evaluate these expressions. So pause the video, try A, B, and C. When you're done, press play, and we're going to go over it. All right, welcome back. We evaluated -3 to the 3rd power. You should have done -3 times -3 times -3. Keeping that negative included. -3 times -3 gives me a +9. But now I have a +9 times a -3. That actually gives me a -27. then the next one, our negative stays out front while we do 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So I actually get negative 27 again. Notice how both of those answers were negative, but if you notice, part A, the negatives were included, but if we have an odd amount of negatives, our answer is going to end up being negative. Whereas up here, we had we had an even amount of negatives, so our answer was positive. If it's an odd number of negatives, it's going to be negative. So that's okay, that can happen sometimes. And the last one, write it as a power. So my base is 1/4, and you should have counted up. How many 1/4 do I have? 5. So you should have 1/4 to the 5th power. Give yourself a pat on the back if you got all of those correct. We're going to move to page 2. Our 16.1 lesson is being continued here. All right, let's look at example 3. We're going to evaluate, so we're going to solve each expression. Now, we're going to have to use the orders of operations here. Think of PEMDAS. Maybe you're going to write it up top to remember. I don't see any parentheses, but next I do see exponents. So let's do those first. Let's evaluate what 3 to the 4th power is. So you're multiplying 3 together 4 times. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I'm going to rewrite what we have so far. So parentheses, exponents, next, multiplication or division. I see there's multiplication happening. So multiply 2 times 81. You get 162. And our last step is to add those together. All right, let's move on to part B. I see some powers happening, so let's evaluate both of those. 3 to the 3rd power, multiply 3 together 3 times. 3 times 3 is 9, 9 times 3 is 27. And then 8 squared, or 8 times 8, gives us 64. Keep going along with our orders of operations. I should do my division next. So 64 divided by 2 gives me 32. So now I have 27 minus 32. If you want to do keep, change, you can. Different signs you subtract. Take the sign of the larger. All right, pause the video, do A, B, and C here. Try these 3 out. Press play when you are done so we can go over it. All right, welcome back. Part A, we should have multiplied a negative 1/6 together 3 times. We're including that negative. So if we multiply all our numerators together, 1 times 1 times 1 just gives us 1. Negative times a negative gives us a positive. Positive times a negative should give us a negative answer. And now multiply your denominators together. 6 times 6 is 36. 36 times 6 gives us 216. Fix that if you need to. Give yourself a nice check or star if you got that correct. Part B, maybe I should have pointed this out to you. Hopefully you maybe noticed these are absolute value signs. So if you didn't know that before, now you know it. You might want to pause and fix that if you need to. But let's keep going along. Inside of those absolute value signs, we want to evaluate what we can. Let's do our powers first. That negative is not included, so you're just doing like negative 3 times 3 times 3, which should have given you a negative 27. And now you're doing negative 27 divided by a positive 27. Negative divided by a positive gives you a negative. 27 divided by 27 gives you 1. Now take the absolute value of that. Remember, absolute value is making everything positive. So it's a positive 1. Our last example, C here, I'm going to do my power. So I'm multiplying 2 together 5 times. So if you need to write it out, write it out. Plug it into your calculator if you need to. When you do 2 times 2 times 2 times 2 times 2, you should have gotten 32. Next, I would do my multiplication before I can do any subtraction. So half of 32 is 16. 9 minus 16 gives us a negative 7. If you needed to, you could put that right in your calculator. We have calculators now. Do 9 minus 16 should give you a negative 7. This last example I think is extensive. I'm not going to go over it through the video because I think it would take way too much time. What I am going to do is I will post my work to these notes later in the chapter. But for now, if you want to try it out, try it out. I think it's an extensive problem that you don't need to know at this time, but I will show you the work in case you're curious for it. If we were in class, I would go through it, but I think it's a little much for us to do through video. So we're going to stop right there for lesson 1. Have a great day, guys.